Hi everybody, Blair Fraser here at UE Systems. Thank you again for taking the time to look at the OnTrak system. The OnTrak system was designed to meet three common challenges we have with IIoT remote monitoring systems: easy, affordability, and openness. And we believe we have designed what is industry's most easy, affordable, and open online bearing lubrication and health monitoring system. So the OnTrak, it's a 16-channel remote bearing monitoring system designed first and foremost to be proactive, to identify the lubrication needs of your bearings and warn users about the potential issues at the earliest possible point. Why is it easy? Why is the OnTrak system easy? And when we look at using ultrasound, it is typically seen as an easy technology to use and understand. And we wanted that aspect to go across the entire OnTrak system. It's easy to install, it's easy to maintain, and most importantly, it's easy to gather actionable insights out of the box to determine when and how much grease is required and when early onset of failure starts to happen in your bearing. We say it's descriptive and prescriptive insights out of the box. The OnTrak was designed to be proactive in helping reduce what can cause up to 80% of premature bearing failures, which is lubrication problems. We're addressing specifically when a bearing requires lubrication and precisely how much lubrication is required. To do this, we use prescriptive alerts and information coming from the OnTrak system. This is an example of one of the gauges that is available in our UE Insights platform. What it allows us to do is quickly visualize the health status of a bearing, when it requires lubrication, and when it is starting to fail. There is no advanced learning curves, there is no advanced analytics required. This is prescriptive insights directly out of the OnTrak unit. The OnTrak system was designed specifically to be able to perform ultrasound guided lubrication. This means the OnTrak is capable of gathering information in 1 second intervals and provide that information on any device anywhere in the world. As the operator adds grease, he or she will notice a gradual drop in the decibels live on any device. Once that level falls back to the baseline, the bearing is sufficiently lubricated. We designed the OnTrak to be open. We built in common automation protocols like Modbus and open REST APIs, which allows you to take data where you want to take it. You're not limited to using the OnTrak just with the UE systems software, but you can also bring it into CMMS systems like Maximo, SAP. You can bring it into your Historian, Wonderware, OSI Pi, IP21, as well as other cloud platforms like IBM Watson, PTC ThingWorks, Microsoft Azure, and Amazon Web Services. We have also designed this system to be affordable. Affordable in terms of the cost of installation, the cost of routine maintenance, which is very, very little. And also how you can purchase this unit. Whether you're using COPEX or operation budget, there is a plan in place to allow you to affordably monitor your critical and essential assets in your facility. So how is it simple? First of all, it's designed to be proactive, notifying you of lubrication needs that cause up to 80% of bearing failures. It has insights out of the box. There is no need for advanced analytics, calculations, data transformations, or long learning periods. With 3 network options, Ethernet, cell, or Wi-Fi, the OnTrak system is designed to fit into your architecture, not your architecture fit the OnTrak system. There is no confusing licensing by users or devices. Access the insights on any device anywhere in the world. You also, with the UE Insights, you can create unlimited dashboards, which means you can view this data how you want to see it. And most importantly, it's your data. Want the data in your own system? We are not locking you in to our software. You can bring it to any other system, database, or cloud. It's designed to be open, allowing you to be in control of where this data goes. What I want to show you next is how easy and simple it is to use the OnTrak data. Our customer has given us permission to share their case study and share the data with you live. They have installed an OnTrak system on their cooling towers. The example I'm going to show you is one cooling tower that has a motor and a belt-driven fan. They have 4 sensors installed on this cooling tower. 2 on the motor, the inboard and outboard bearing, and 2 on the fan, the inboard and outboard bearing. To give you an idea of what the installation looks like and how robust this system is, this is an example of one of the installations of these sensors. As you can see, the sensor, first of all, is installed in an outdoor application. The sensor is designed to be in industrial environments, completely weatherproof, dustproof, and also it's designed not to pick up any ambient noise from mechanical or electrical equipment. This sensor is shielded from the tip of the sensor all the way back to the OnTrak system, allowing you to easily install this sensor and have that sensor last years, and years with no maintenance on that sensor. So let's take a look at what the data looks like. So what we're seeing now is the UE Insight dashboard. This is live data coming in from our customer's OnTrak system monitoring the cooling tower. Now they have custom built this dashboard the way they want to visualize the insights coming from this system. The dashboard is made up of available widgets, which include everything you would expect. So single values, time series, analytical, and even administration functions. So the first widget they have been able to utilize is the alarm widget. This shows the alarms that have been in place or have been active for this system over a certain period of time. Now, there is no alarms currently in this system, so we have generated some fake alarms to show you what this looks like. So I can click on any one of these alarms and it gives me the information you would expect to get. What I want you to concentrate here is this alert description. Create work order to lubricate cooling tower unit 1014 motor inboard bearing. This is what we call that very prescriptive alert. So you know exactly what to do. Even if you don't understand the context or have a technical background, if a planner or scheduler was to get this alert, there is a very prescriptive action on what to take. Now the other widgets they've been able to use are graphs, real-time values, gauges, and some buttons. So I'll show you what this looks like. So what we'll do is we'll take a look at this bearing here. This is the motor outboard bearing of this cooling tower. Right now it's reading 14.0 decibels. I'll ask you to keep an eye on that. As we go through this demonstration, this will change every minute. So that 14.0 decibels isn't very indicative unless you know what that baseline is. Right now, I can see from this graph that green line indicates that baseline value, which is set at 15. So right now I am reading very close to my baseline, which is a great thing. You'll notice on this trend that the values do go up and down. There are peaks and valleys, and that does happen in terms of gathering this data that frequent. So what we've done is we created a gauge widget, which allows the user to be able to take an average over a certain period of time. In this case, they're using a 10-minute average, which allows us to take away those peaks and valleys. And what we can see here is that arrow is in the green zone. That indicates a working, healthy bearing. If that had been in the blue zone, indicates it needs lubrication, and if it was in the yellow, the early onset of failure, and red is a critical failure. And I can do this for the motor inboard bearing as well. As I can see, I am reading 2.9 with a baseline of 3. I am at my baseline, which is great. If I scroll down to the fan inboard bearing, you will notice it is in the blue zone. This is a bearing that requires lubrication. In fact, the customer knows this and will go out and lubricate it. So right now, that inboard bearing is reading 19.1 with a baseline of 4 decibels. So we are 15 decibels over that baseline, which is concerning, which means that bearing requires lubrication before some damage is set to that. So what that customer would then go do is use the OnTrak to lubricate that device. So to make this clearer, I'm going to show you what it looks like for the last 10 minutes. So I can easily change this graph to go through and show us the last 10 minutes. So what it's going to do here is show that trend over the last minute. What I'm going to do now is hit this live mode button. What this allows me to do is send a command from my computer to the UE Insights cloud, and from the cloud over a cellular connection to that customer's OnTrak sitting on top of a roof monitoring the cooling tower. And what it's going to do in that next 1 minute interval is it's going to send a command saying, instead of updating every minute, I would like you to update every second. What this allows the user to do is go next to that bearing. using any mobile connected device and be able to get that real-time information. So whether that connected device is a cell phone, a laptop, a tablet, it doesn't matter. And what I can see here is instead of updating every minute, we are updating at a frequency of every second. And that is very powerful when we start to look at how we can start to troubleshoot and maintain our assets. And to give you an idea of what this would look like from a mobile viewpoint of view is I am going to enter what is called the developer's mode of Google Chrome. What it allows me to do is show you and demonstrate what this data would look like on a mobile device. So I am showing you on a mobile, an iPhone X, what this data looks like. So I am able to scroll through with my finger and see all this real-time data. And what you can see here is this trend. So this is that bearing I was talking about. In real time on my mobile device, I can see this real-time information. No matter where I am in the world, it is like I'm standing next to that bearing, listening to it to make sure I sufficiently lubricate that bearing. And what I can do is go back out of developer's mode and show you again what it looks like in a normal mode. The same view can be seen on a large screen TV, a mobile device, a Kindle, it doesn't matter. What is great about the UE Insights is I can create a number of dashboards. I can create dashboards just to look at data, and I can take a look at that data on many different aspects of slicing that data. Here I'm using a 24-hour trend of that specific bearing that we had that lubrication issue. And what's interesting about this, day after day, starting on August 6th, I can see my mean value of decibels was 4.3. The next day it was 6.8. The next day it was 7.8. The next day it was 13, almost 14. Then it went up to 17, right? So this is an indication of how I can further troubleshoot this data. Now, of course, I can do all sorts of analytics in this platform. I can even export it into a CSV, but I wanted to show you quickly the flexibility and simplicity of being able to view this information. I hope you were able to get a quick overview of this system, of this use case, and I encourage you, if you find this interesting, we can spend a lot more time and go dive into this particular use case using live data a lot deeper. I appreciate your time and hope to hear from you.